Okay, let's now see another application of the abstract classes. Let's see how we can play with the return value for the methods, which we also spoke about when we talk about the student management system, having polymorphic return type. Let's now consider this new class here called Polygon constructor. Okay, and we have a polygon accessor method here. You can see get polygon here. It has a parameter which will be just an array of double. So if you really want to create a triangle, in that case, you're going to pass an array of length 3. If you want to return a rectangle dynamically, you're going to pass an array of length 4. So that'll be the idea. And you can look at the return type over here, polygon. So the return type being polygon means dynamically, the return value can either be a rectangle or a triangle. The descendant class is of the abstract class polygon. Remember, it cannot be polygon because polygon cannot be the dynamic type at the runtime. Okay. On the other hand, think about the alternative. What if I put, let's say, only rectangle over here? If I only put rectangle over here, then the return value can only be the descendant class of rectangle only. In that case, it will only be rectangle. All right. Let's now take a look at the implementation quickly, and then we'll look at some example of manipulating the method. Let's say we got to return the value p eventually to be returned. You can see I deliberately chose the static type of p matching the return type. So that's actually more obvious to you about what can be happening at runtime. Just initially no, but conditionally we're gonna say either if the size, which is the parameter over here, if the length of that is actually 3, so that means we want to return a triangle. So that means we're gonna say p polymorphically is going to be assigned to a new triangle, and we know that this is valid, right? I will illustrate that a little bit more when we get to the iPad. Otherwise, what else if the length of the size parameter over here is actually 4, so that means we want to create a rectangle. In that case, we simply get the first and second elements in the array as the width and the length, right? Like how we did it before. You can see polymorphically p can either be a triangle or it can either be a triangle over here. Let me see if I can highlight. Either a triangle, sorry, I cannot. Either a triangle or a rectangle over here, right? Either way, depends. And eventually we're going to return p. All right, and then we also got one method here, simply grow, just for fun over here. You can see polygon here, again, it is polymorphic, right? So dynamically, the argument can either be a rectangle or triangle. And then p to grow, that's what we're going to see. We're going to manipulate later. All right, and then you can see polymorphism if you look at line number 2. So this will be polymorphism because the polygon, eventually that's going to be returned. So remember the return statements. For that to be valid, the return values, the return expression static type, which is polygon, must be a descendant class of the return type, which is polygon here as well. I will make notes on the iPad in a moment. And also line number 5, this is also this is actually polymorphism as well, because p statically polygon can be fulfilled by either a triangle or rectangle, both being its descendant classes, right? Okay, let's now take a look at one example together. Okay. Again, so this is the inheritance hierarchy we're assuming. We got polygon, and also we got rectangle, we got triangle. Okay, and we have to make sure we actually got the different methods. So we got abstract over here, and also we got abstract over here, right? Just to remind you. And the method that's going to be all the method that will be inherited verbatim to both classes, both subclasses will be the grow and also the get parameter over here. But for the get area, it is actually going to have its overridden version in here versus over here using different formula. Okay, let's look at the polygon collector. I want to make a notes quickly for, together with you. Especially, you can see this polygon over here. So this is the static type for return value, okay? Or you can think about a static return type, either way, okay? So this one over here is the static type of return value, or RV. Static type of return value. And then we can either dynamically, so of course you can judge to see whether or not these two substitutions, this one here and also this one here, they're both valid because you can see the polygon that we declare over here, polygon over here, right? You can see the triangle can fulfill the expectation for the static type of P, which is polygon. Rectangle can fulfill the expectation of the static type of P, which is also polygon, right? And what I really want to say is this return expression over here, right? This expression over here is valid, right? Okay, I'm not going to let you pause the video. I'm going to tell you the answer right away, but make sure you will be able to answer a question like this later in the test or in the exam. So it is valid because the expression to return, in this case, we're only returning P, right, directly. P, in this case, P has static type polygon, right? You can see P was declared to be polygon as a static type, right? Static type polygon, which is a descendant class, descendants of the return type, which is polygon. Right? Polygon is simply the descending class of itself, so that's okay, right? Again, the static type for this expression to return is actually declared to be polygon, which is a descending class of polygon, meaning that whatever we are returning can fulfill the expectation of the return value, the return type. Okay, it's really important for you to actually understand what I just said. Okay, so the expression to return, and also, okay, let me do it again. This is the expression to return. This is its static type over here, and which fulfill the expectation for the return type. Okay, so these are the critical points for you to review. And let's now take a look at this example code, which also appear on your slides. Let's take a look very quickly. So there are basically two parts, right? Let me just talk about two parts in a little bit faster speed. So you can also study the code in detail yourself later. Okay, so the first part here, we're simply saying P. Let's start with it. Okay, by the way, the P over here, as you will see in the slides, the P over here was also declared earlier. Okay, so we are using the same reference variable P that was starting from here, right? Polygon P. When you go to the later slide, you will see exactly what I meant. I simply broke down the fragment of code in the slide into different pieces, and we can talk about them in different fragments. That's easier for your learning, I thought. Anyway, so the P is declared to be polygon. That's what we assume. All right. So here we say P is assigned to the polygon constructor that get polygon, right? Let's now first of all decide whether or not this particular substitution is actually valid, right? Is it valid? Indeed, it is valid. Because if you look at what is the static type from polygon constructor that get polygon, you can see get polygon actually got this particular return type over here, right? Okay. So this one has the static type polygon, right? That's very important for you to identify. Valid because the return value's static type, which is polygon, is a descendant class, is a descendants of P's static type. And as I said, P's static type is as declared before, which is polygon. And similarly, you can also argue about this substitution over here also being valid over here. The only difference is you can see in one case we are trying to pass the rectangle size array, which is of size 4. The other case we are passing triangle sides over here, which is another array of size 3. It's different, right? And as we know before, I can let you do the detailed tracing. You can see depending on the length of the argument size, right? If it is 3, we're going to return a triangle dynamically. If the length is 4, we're going to return a rectangle dynamically, right? So we know, let's say, let me do, let's say for this, the first one here, let me use pink over here. So for the first one, P, dynamically, because the argument is going to be an array of length 4. So that means we're going to return a triangle. Sorry, we're going to return a rectangle. Beg your pardon. So the first one here is going to return a rectangle. Right, over here, that's going to be invoke. This part over here. Okay, so rectangle is going to be, let's say, 3, 4, 3, 4. So 3, 4, 3, 4. And P is going to be assigned to that value, right? So P is actually going to point to rectangle. That's what's going to happen. Dynamically, we know that P is rectangle. And now, given that P has the dynamic type, right? The P, which we're going to do the various manipulation, but we know that its dynamic type at the moment is actually rectangle. All right? And we know that for instance of check, we want to see whether or not the dynamic type of the variable can fulfill the type that's to the right of the instance of operator, right? Given that dynamic type is actually rectangle, can it fulfill polygon? Indeed, it can. Can rectangle fulfill rectangle? Yes. Can rectangle fulfill triangle? No, it cannot, right? So you can see specifically, it's important to know this one here should be a no, right? Otherwise, other two should be yes. And also, let me go further. For dynamic binding, if I try to say get parameter over here, there's only a single version that's inherited to rectangle. There's only a single version that's inherited to over here, right? As we said before. So this is going to invoke the version from polygon version. And what about get area? Given that dynamic type for P is actually a rectangle, so it's going to invoke the version that's declared in rectangle, which will just do the width multiplied by length, right? And we know that very well. So that will be the rectangle version. Right? Hopefully so far so good. And then we can do a little bit more manipulation, which I'll show to you quickly over here. And then for the rest, you will just be able to study yourself in a similar way. What about we say polygon constructor that grow and then P? You can see what we have is P is the argument. P currently is pointing to rectangle, right? Let's not lose the big picture. And what about we say con the grow? So we're basically calling this grow method over here. So it was simply whatever P it is, right? It's a call by value, really. You can think about it's call by value. Okay, over here, it's actually call by value. Well, they happen to have the same name. So you can think about the method parameter is actually also going to point to the same object as P argument is pointing to, right? You can think about it. Don't get confused again. And when we talk about call by value, the namespaces, the scope for the parameter versus the argument are simply different. So even though they have the same name, the compiler, even the programmer should be able to distinguish between them. Okay. So now if I say P that grow, I really meant P pointing to this object that grow. So that one there is actually going to grow. Well, it's going to call this grow over here, of course, right? There's only one version, which is going to increment each side by 1. So 3 to 4, 4 to 5, 3 to 4, and also 4 to 5. That's what's going to happen, right? All right, as an exercise, I want you to do the following, okay, as an exercise. So you can see for the remaining code, starting from here to here, what's going to happen is we are passing a different argument value for calling the constructor.getPolygon, right? That's what we're doing, okay? So we know that the return value is actually going to be a triangle instead because we're actually executing this branch, right? That's what we're going to do. And I want you to really try to visualize what's happening here. So this P, rather than pointing to here, is going to point to some other objects depending on what the return value is from here. And also try to understand the instance of checks. We spoke about something similar already. And also think about dynamic binding. In this case, what version of the get parameter and also get area is going to be invoked, given that dynamic type of P is going to change after this particular reassignments. Okay, and then you can also execute a grow method that's defined in over here, which will be executed in a similar way as we spoke about, right? Okay, so that's about the last example I would like to speak about for the abstract classes. I hope it's okay because we also spoke about something very similar for the student management system, polymorphic return type. Let me now go back to the slide to see what's left. Okay, so that's okay. That's what I meant. This polygon tester really puts everything together. So this is part 1 of the example that we spoke about, right? And also this is part 2 about using the polygon collector, and this is part number 3 about using the polygon constructor, right? You can see the P over here that we're using over here is simply just declared in the very beginning. So hopefully there's no confusion for you. It's just a big tester that we're using. But we're only using a single polygon P. I'm going to show you the Eclipse example. In this time, I made the source code available to you because I want you to do something more challenging. Well, not really challenging, but something that's to help you get more insight into the code. I'll get there in a moment. Okay, so that's the code, and I'm going to summarize about abstract class, what abstract classes are, and give you some general guidance. Before I do that, let me show you quickly the Eclipse. Okay. So you can import the project's example abstract classes, okay, and then you expand the project. You will see under the source folder we got model, and also we got tests over here, right? So we got all the model classes: polygon, rectangle, triangle, polygon collector, and polygon constructor, right? Everything here, and it will be your responsibility to really play with them and make sure you understand everything, right? You really want to do that. Let me just show to you how you can play with them. Just give you one example. For example, if I go to, let's say, polygon constructor tester, which is what we just did, right? You can see here we're calling pc.getPolygon over here, and also pc.getPolygon over here, right? Size 1 is of only 2, of size 2. In that case, I'm gonna create a rectangle, right? And in this case, I'm creating a triangle over here. Okay, let's see. So if I put a breakpoint over here, for example, right? If I do that, and I launch the debugger, and then let me say switch to the debug perspective, right? We haven't seen debugger for quite a while, but you shouldn't abandon that. That's really something up to your try and play. Okay, so now you can see at the moment, let's go back to variable. At the moment, P is simply null, right? We haven't executed line number 11 just yet. And let me now step into it. If I step into, you can see now we are in the getPolygon method in the polygon constructor, right? The size argument is simply of size 2. So that means we want to create the width and length for the rectangle. So if I say step over, and also it's not 3, right? So I think the condition here is a little bit different from what I showed in the page, but they're kind of consistent. I think in the case of the rectangle, I think rather than 4, we simply say 2. Right, so we don't have to repeat the width and length, right? But similar idea, so don't get confused. All right, so now it's 2. So now that means we're gonna go into this branch. So P is gonna be assigned to new rectangle. Of course, as an exercise, you can also step into the constructor for rectangle to see exactly how things work. Okay, I'll leave that to you. Okay, if I say step over and now P. Before I do that, you can see P here. The value is rectangle. If you look at the address, it's actually rectangle, right? Even more, let me just clean the expression here. That's really important to see this as well. Let me show to you, right? You can see here, we can say P, right? We can see dynamically, if you expand the objects, dynamically is really a rectangle over here, right? You can see the size over here is actually 4. 1, 2, 3, 4. And how can I check the dynamic type? Let's use an instance of operator. If I say P instance of, for example, polygon, can it fulfill polygon? Indeed, it can. Given that dynamic type is actually rectangle, P instance of rectangle, it will be true. But what about, can P being a rectangle fulfill triangle? False, right? That's consistent with what we said in the lecture. All right. So I'm just showing you one example about how you can play with the code. Use the debugger, step into the critical methods to see how the dynamic types for the methods actually change. All right. I want to do one more. Okay, and then step over. Okay, and step over. You know what? This is not really over here, but I want to add this line over here, right? So once we get this P, let's say that's something you can type as well. System.out.println line. And let's say p.getArea over here, right? Okay, what I want to do is I want to see which version of the getArea will be called. That's also very important to see. Okay, That's something we didn't quite do in the inheritance lecture. Let's complete the picture right now. Okay, so now you can see the breakpoint set in line number 12 over here, right? We know that after this assignments, P's dynamic type is going to be rectangle, right? So now that means because dynamic binding, P.get area should really invoke the version corresponding to the dynamic type, which is rectangle. Let's try. Launch the debugger. Okay, line number 12. And let me say step into over here, right? You can see the get area over here is from the rectangle. All right, remember that. And let's now say step over. Okay, you know what? Let me, for completeness, I should have put another version over here. Can I just copy this line? Let me just do it once more, so you can see exactly what my intention is. Oh, sorry. Let me just paste it over here. Okay. All right. Let me do it once more. If I do debug, okay. So let's now, if I step into, it's going to invoke the version corresponding to the dynamic type of P, which is rectangle. Step into, you can see that's a get area version from rectangle. Very good. Step over. And now, after executing this line, when I say P is assigned to get polygon size 2, and that size has an array of size 3, right? If you actually step into this, you will see that, so now, because size, the length will be equal to 3, so that means we're actually going to return dynamically a triangle. If I say step over, right, that's the branch. And now in this case, P, as you can see the different evaluation for instance of. I'll let you double check with that to make sure it makes sense. And but if you look at the P here, the address is a triangle object's address. Makes sense. If I say step over, okay, so now which version? Oh, sorry, step over one more time. Which version of the get area is going to be invoked? Earlier, we know that this one here is going to invoke the rectangle version, but now dynamic type for the context object P has been changed to triangle, right? So now if I say step into, we're going to see the get area that's in the triangle objects, the triangle class, right? That's the overrated version. Okay, hopefully you're following, and that's really the kind of exercise I want you to do with all the other examples, right? You want to use the debugger to figure out how polymorphism and dynamic binding actually work at the runtime. Really crucial exercise to do. Okay, all the source code is available to you, so you should do the rest, I hope. Okay, let's now summarize about abstract classes. So an abstract class can typically has at least one method with no implementation body, right? Like a polygon, at least one. If all the methods are not abstract, meaning that all the methods have some implementation, in that case, there's no abstract, right? So you may define some common implementation inherited to subclasses, meaning that those implemented methods will not be abstract. Only those for which you don't know about its implementation just yet, you will actually put them as abstract, like getting the area for polygon. You will only get to the rectangle or triangle subclasses, and then you will know about how to implement them. Before that, you simply don't know how to do that. So that's why abstract will be useful. It's recommended to use an abstract class as the static type of in different contexts, right? We spoke about a polygon P, right? In that case, you allowed dynamically P to be pointing to either rectangle or triangle objects. Also, method parameter, that's how we can, for example, well, we have something called add polygon, right? In that case, you will be able to add different polygon. But this one is also good because you're not allowed either rectangle objects or triangle object to be passed as arguments, and you can grow them, right? Rather than creating two methods instead. Also, for the method return type, you can see we can return dynamically either a rectangle or a triangle. But statically, it's just polygon, right? So the point is for the static type of variable, the static type for parameters, and the static type for return value, we just want to be as general as possible in the hierarchy, right? Think about what expectation you want on those values. Well, it is forbidden to really say, for example, new polygon, because, as we said before, if it was valid, it can lead to some crash. Because, for example, for polygon, the get area method is simply not implemented. So that's why it will not compile. Instead, what you want to do is, you want to say polygon P, you want to declare the static type to be some abstract class, if that's available. In that case, you can just make sure you can get dynamically either of its descendant classes, like a rectangle or triangle, right? So it's a very quick summary about how the abstract class can be useful. And let's now move on to another flavor of the inheritance, which is called interfaces.